Okay, in this video, we're going to look at a data set of, this is a data set of data about stars that are within 15 parsecs of Earth. And what we're going to do is we're going to load that data set into a Java program and use the processing libraries to visualize that data set. So along the way, also, we're going to make a Java class to encapsulate the data from a single row. So in other words, the information about a single star, we're going to make a Java class to encapsulate that. And then we're actually going to use an array list. And an array list is similar to an array. So it's a really cool data structure in Java that it's like an array, but it's an array that can grow and shrink. So we're going to load our data set from a CSV file into an array list of Java objects of this type star that we're going to make. So that's just a step that we're going to do along the way. Okay, so to get started, let's have a look at the data set that we're going to visualize. So I'm just going to find that data set on my computer here. So it's documents, courses, OOP. And here we go, Java folder here. And here's the data folder. By the way, you should clone the repository for this course if you need to get the starter code here. And this is the URL that you need to go to in order to get all of the code that I'm working on today. So it's that URL there, github.com, scooter500, OOP 2018-2019. So let's look at, when you clone the repository, you get this structure here, and here's the Java folder. Inside the Java folder, there's this folder called data. And inside here is a CSV file. So I'm just going to open up this CSV file in Visual Studio Code. And this is what a CSV file looks like. So CSV stands for comma separated values. So if I press Shift, Control, and plus, I can zoom in there. And you can see that this is just like an ordinary text file. But what have we got here? Basically, every row from this data set that we are interested in is stored on a separate line in this file. So that's the first thing about CSV files. CSV files consist of each row is on a separate line, and they're all separated with like a carriage return at the end of every line, and then you're on to the next row. The next thing about this CSV file is that it is separated, all of the columns are actually separated with commas here. So if you notice, like this is basically column number 0, and then column number 1, column number 2, column number 3, column number 4, and so on. Here are some columns. You can see where my mouse or my cursor is hovering over, and that's some columns with no data or no values stored in them. So the other thing about this CSV file is this CSV file contains a header row, and that means that the 0th row, or like the very first row in the file, contains the headers. In other words, the column headings, right? So that's HAB HYG, and then HIP, and then HAB question mark, and then display name, and then HYG, and then all these other column names that we see here. So we're not actually interested in all of these columns. In order to visualize this data set, let me see, we're only interested in a subset of them. So what are we interested in here? Actually, let me just go along here and see the ones of interest. Well, display name is of interest. Okay, that's cool. So I'm going to just make note of that. That's one that we're going to get. And what else do we need here? We need to get the distance. All right, so there's that distance column there. And then we need to get the X, G, Y, G, and Z, G columns, because these columns are the location of the star in Cartesian coordinates. So in other words, the X, Y, and Z coordinates in parsecs of this particular star. And then we're also going to the abs mag as well, which is basically the size of the star. And I think there's one other one I want to get here, which is basically the HAB one, right? So the HAB one is numeric. Display name I know is a string. And X, G, Y, G, and Z, G. I'm going to use floats to store these, and then the abs mag is a float as well, because you can see that they're floating point values. You can also take any CSV file, and if you have Excel installed, you can load up the CSV file into Excel. And Excel does a nice job of basically displaying everything like basically in the columns and rows format. So it just goes through and it looks for the commas, and it separates everything out based on the commas. So I'm going to close that Excel spreadsheet there, and that's what the CSV file looks like. One thing to say is that when we're loading CSV files using processing and using this Java framework that we're linking with processing libraries, they should be in a folder called data. Okay, so I've got source, which is basically my Java source code, I have bin here, which is going to be the output of my Java compile, and then there's lib, which is the processing libraries are all in here. And just so that everybody, in case you're watching this video and you're not part of the course, there's a couple of extra files in here, .classpath and .project, that allow us to load this folder structure into Visual Studio Code and then compile and run our Java programs. And then there's also shell scripts here as well. You can run these shell scripts, compile to compile it, and then run to run it, or if you're on the Mac, it's mcompile and mrun. Let me just make sure my video is still recording. Excellent. Okay. So that's the CSV file. Actually, maybe I'll just show you what the visualization is going to look like when it's all finished. And then let's go and write some Java code. Here it is. This is from the lab test. And that's what it's going to look like. Basically, we're going to load up all of the stars, and we're going to be able to plot them on this 2D grid here. And the size of these circles is basically going to be, the size is based on the absolute magnitude, and then we're going to be able to click on two stars here and calculate the distance in parsecs. You can see that shows up at the bottom there between those two stars. Okay, all right, so I'm going to quit that one, and then let's go over and get started. So the first thing I'm going to do here is go into the source folder, i.e. dit, and then let's make a new class. So I'm just going to click new text document. I'm going to rename that text document to be starmap.java. And again, just to make sure everybody, it's actually, you have this thing enabled here. You've got view file name extensions should be checked, right? So that you can see that the file actually has a .txt extension and you can rename it to .java. So I'm going to go over to Visual Studio Code here. And just to show you, I'm going to go File, Open Folder, and then that Java folder, that's the folder that I want to actually select. And once you select that Java folder, Visual Studio Code then knows that this is a Java project and is able to compile this Java code for us and debug in Visual Studio Code. And there's starmap.java. All right, so let's start putting some code into starmap.java. This class, by the way, is like a controller class. This is going to extend papplet like the other classes that we've made, and that's just so we can do make use of the drawing methods in the processing papplet class. All right, so first thing, it's in the package i.e. dit. So the first thing we got to type here is package ie.dit. Excellent. Okay, next thing we're going to do is put a public class starmap. And we remember in Java that the file is called starmap with an uppercase S and an uppercase M, and that this has to match the name of the class here. And now I'm going to make this, like we did with our other classes, extend papplet. And that's just, like I say, because the processing applet library, processing papplet class, has got lots of cool methods on it that will enable us to do drawing without too much fuss. All right, so it extends papplet, open and close curly brackets here. And you notice the Visual Studio Code has put in this statement, import processing.core.papplet. And, if you didn't have that statement, you could just write the fully qualified class name like this. And then you wouldn't need this line of code. All right, that's all the import statement does for us in Java. So we're importing that so the compiler knows where to find the papplet class. And then let's put the standard methods on the papplet. So we got public void setup, public void settings is the first one, okay? And settings is where we decide what is the size of the window we want to create. So size 800, 800. So that gives us a drawing window of size 800 by 800. Again, size is a method on papplet, and because we extend papplet in starmap, we are able to use all of the methods of the papplet class. So that's the first thing we're going to do. So let's just put in, let's put in the setup code, right? So void setup. And for now, don't need to do anything. Okay, let's write a method on this class, public void setup, to load that data set, right? So let's go public void load data. And we'll call that method from setup. Here we go, load data. So, one thing we should do before we go any further is to add code to main.java to instantiate that star map class, and then to call, yeah, just basically to instantiate it. Well, to basically get processing to run that one. Okay, so this is kind of like what I would call boilerplate code. In other words, it's just code that goes into any program that we want to use. The applet, this is exactly the same code. So star map, I'm just going to copy the one from arrays, and then it's going to be equals new star map, and then run main equals new main. I'm just going to call that method star map. So there we go. And if you want, even at this stage, you can hit the run button and it will run that. Just create an empty window and nothing's going to happen. Cool. So let's click save. All right, everything's saved. Now here's star map. Now we're into the interesting part, load data. So how do we get that text file into our Java program? How do we read it in row by row, line by line from the file? And it turns out there's actually several different ways of doing that. We can use the standard Java file IO libraries, and we can use possibly a thing called a string tokenizer. So there's lots of ways to do it using the JDK classes, but for this video, and I may come back to that in a future video, but for this video, we're just going to use the processing libraries, because processing, this is just going to enable us. This is not the core part of this. The core part of this is so that you understand about classes and array lists, and maybe some computational thinking, but so we just load the data set using the processing libraries, which are really, really handy, and they allow us to basically just load the data set without having to write too much code. So this is how it looks. I'm going to use a couple of classes built into processing as well. One of them is the table class, right? And you notice now in Visual Studio Code is saying which table class do you want to pick, because there's lots of table classes. We want the one from processing.data. That is the package that we want, right? So if I press enter, Visual Studio Code will put import processing.data.table. So this table class is a class built into processing that encapsulates tabular data. So you can construct one, and there's lots of things you can do with a table object, but we're just going to load the table. We're just going to load that data set into the table object, right? So the method that you call to load that data set into a table object is a load table. Load table. All right, so this takes one and then an optional parameter. The first parameter is the file name. And so let's jump over to the folder and copy and paste the file name just to make sure that I don't type that file name incorrectly. So I come over to here to the data folder. There's that file name. So I'm just going to single click on it, select everything there. Come back over here into my star map class and then paste in that file name like that. Second parameter I'm going to pass in here is the word header. So that just tells the load table method that this CSV file has a header row. And if you're curious about these classes, like, let me just show you where you find the reference for these classes. So table, if I type processing. So this is the table object, right? And you can see the table object reference here, and this is all the methods on the table object. So if you want more information about the table object, you can look up the processing reference there to find that out, right? So there's the table object loaded. Okay, so this has actually gone to the CSV file, opened up that file, and then it has parsed it out line by line, and it is loaded into this table object that we can now query about that data set. So essentially the data set is in a Java object called table now, right? So let's see what we can do with this. So table dot, and see what methods are on the table. table dot. So add column, add row, copy, clear rows, find row. So lots of useful methods here. Get column count, get row count, and so on. So like basically, let's just see, we can try and do some simple stuff with this. Let's see if I just want to iterate over that table and print out some of the columns, right? So you can, there's several ways you can do this. Let's write it using an ordinary for loop. First of all, you can go for int I equals 0, semicolon I is less than table dot row count, get row count. Okay, so that's the method there. get row count, semicolon, I++. So that's going to go row by row. And then you can go table row. Table row. And table row encapsulates a single row. So you can do table row, row equals table dot get row. And then you can pass in I like that, and you're able to get a whole row of data from the data set, from that text file. So again, it's loaded the text file here. Now it's in memory, so we're just actually doing stuff in memory. And then you can do something like this: system dot out dot println, and you can do row dot get column. So there's lots of things you can do here. You can do, get column count. It's going to give you the column count and so on. You can get the titles and so on. You can just type, like, I know that I have this row, so you can just type row dot get string, for example, and then you pass in the name of the met string. Oh yeah, okay. So you pass in the name of the column you're looking for. So why don't I actually go and find that CSV file again? There's the CSV file. And say I want to get the display name one. I can take display name here, like this. Copy, paste in like that. And there we go. That's the display name from that row. And let's just do it for one other column. Let's just do it for the HAB question mark, say. HAB question mark. So I'm now going to basically read those two columns and print them out row by row. Okay, so what we should see here when we run this program, what's given the problem here? Import. Oh, that's no problem. Okay, so let's hit F5. Right, Visual Studio will compile and run this program, and the window is going to pop up like this. And if everything went well, then in the output window, oh yeah, what's wrong now? I don't see anything. I is less than table. Dot get row count. What have I done wrong here? Setup. Public void setup, public void settings, load data. Let me set a breakpoint here, F9, just to see does it hit that breakpoint. Load data. So it's hitting the breakpoint. I'm going to hit F10. Table.getRow count jumps in here. Table.getRow. System. Oh, because it's printing out here in the debug console. I was looking at the wrong window. I'm going to hit F9, hit F5, and let it continue. And then here we go. It is now printing out all of that data basically with, on separate lines. Oh yeah, you can see that HAB column in lots of cases is empty, but it's gone through and it's read all of the rows from that CSV file into this table object and then printed them all out row by row. So I'm just going to show you one other way, because this is a nicer way maybe to do this iterating over this data set, right? So maybe I'm going to comment this bit out here, but it's just to show you some of the methods that are on the table object in case you want to find them. There's loads. You can get columns by number, or you can get rows by number, or you can get the column names, whatever you need to get from that data set you can get. Another way to write that above code would be like this: for, which is to use like the Java for each loop. And you can go for table row or colon table dot get rows. Not get rows, table dot rows. That's what it is. Okay, and that returns an iterable type in Java, which means that it can be iterated over using this type of loop here. So what happens here is kind of similar to the above, okay? But what's going to happen now is we don't use the index I to get the current row. Each row gets copied into this variable or, and then this code gets executed. And that's how a for each loop works. So for every row that's in this rows object here, this code is going to get executed. So now we can basically take this code and paste it down here. So, and I call it row. So let's call it row to be consistent. So now for table row colon table dot rows, and it's going to do exactly the same code. So I hit load, run, there we go, debug console, and it's done the same job. Okay, so let's do the next thing. The next thing, let me see, what have we got? Load the data set, print the records. Now what we want to do is think about like doing this like whole project in kind of more OO way. So what we're going to do is we're going to make, instead of like querying this table row object all the time, we're going to make a custom object here, a Java object, to encapsulate a single row. So there's Java source. I'm back into the source folder here, IE DIT, and I'm going to right click on this folder here, and I'm going to click new text document, and I'm going to call this star.java. There's star.java. Yes, I want to change the file name extension. So come back over here to Visual Studio Code. Here's all my files again. Here's star.java. So now I'm going to go public, package ie.dit, and then I'm going to go public class star. This time it doesn't need to extend anything because we're just going to use this as a container for a single row from that file. So here's the star class, right? Package ie.dit again because it's in the folder ie.dit, and we're going to make like what you would call a canonical Java class. This is the way a lot of Java classes are written. So we're going to make our fields in this Java class private, and we're going to make public accessor methods for those private fields. So the fields of interest for us, let's first of all, it's going to be private string display name. So again, this is sort of Java convention here, is that you make your field names begin with a lowercase character and then use uppercase character. Let me see if my video is still going. It is. Excellent. So private string display name. Okay, the hab, let's make that an int. Okay, let's make that private int hab, which is the habitability. And then we have private float xg, private float yg, and then private float zg. And then the last one we have is private float, what is that column called? Let's just get the column name again from the CSV file. So there's the data folder, CSV file. It's called absmag. All right, so it's basically the size. So I'm going to call this abs absmag. It's the size of that star. So these are all private fields now. Okay, so this is the convention in Java. Private means these fields can only be accessed by methods inside this class. So the next thing we need to do is figure out how to get access to these private fields, and the way to do that is by means of what are called accessor methods. So I'm going to write one accessor method, and then I'm going to use Visual Studio Code to basically write the rest of those accessor methods for me. So when you have private fields like this, you're going to make two methods. One method for setting the private field to a value from outside the class that you're going to pass in as a parameter, and another method for returning that value back to like whatever calls that method, right? So let's do that one for display name, right? This is what a public, this is what a set of accessor methods look like. So we go public, so this is the setter, so void set display name. So then we're going to pass in a string like that, and now we want to assign this string parameter to the private field, but they're both the same name, so we need to disambiguate this display name from this display name. And how you do that in Java is by using the this keyword. So this.displayName refers to the string, the private string here. If you go this.displayName equals display name, that's assigning the parameter display name to the private string, and that's what a setter method looks like. So now let's make our getter method for that. Public string get display name, and this method is going to take the private field and return it. So we're going to just return display name. Okay, so that's what the accessor methods look like for the display name field. Accessors always look exactly like this. So once you know how to write one, that's it. They're all pretty much identical. And then these are used all over the place in Java. Even though 99.9% of the time they don't do anything really terribly useful, all they do is just provide access to this private field. It's just a bit of extra code that you find in a lot of Java classes that really often serves no useful purpose. But there you go. So let's do, because it serves no useful purpose and because they're always the same, most IDEs have a way of generating them automatically, and Visual Studio Code does this. So you can go private int hab, and I've right clicked on it there, and there's source action, and it says generate getters and setters. So let's click that button and see what we get. And look at that, we got this method called getAppsMag. Oh my goodness, has it done it for them all? Display name, hab, set hab, get g, set g, get y, excellent. It seems it has actually done it for them all, which is really, really cool. So it's exactly the same sequence of, you know, methods and parameters and stuff, but it has just done it for all of them here. This, by the way, in case you're curious, this is called JavaDoc. And JavaDoc is like self-documenting Java code. So in other words, you type your comments in this format here, and there's lots of special annotations that you can put in. And then you run a program called JavaDoc, and it will basically make API documentation. So it makes a big document in HTML that you can click on with links, and it gives you all of this information about the methods and stuff on your classes. So there's my star class. Okay. So the star class has all these private fields, and now we have a way of setting all of these private fields from these public accessor methods. We could make a constructor on this, but the thing that in Java is if you don't put any constructor on it, then it basically gets a default constructor that does nothing, that just basically sets all their fields to their default values. So why don't we just use that for now? We don't need to put a constructor on it. If we put a constructor on it, maybe we might want to make one that takes all of these private fields and assigns them to the public, takes all of these fields, public parameters, and then maybe assigns them. It's just a little bit like long-winded. Maybe you don't need it. Maybe sometimes you will need it to construct, you know, and pass in these parameters and basically instantiate the Java object and give all of these guys values from parameters. But we're not going to use it this time. We're going to do something different. Okay. So here we are in our p-applet, in our star map p-applet class. And now I have this bit of code here for table row colon table.rows. And then in this case, it's just printing out these values, the display name and the hab. What I want to do now is I want to construct a Java object out of those columns. And I also want to store all those Java objects into some data structure. And the right data structure for us is called an ArrayList, because an ArrayList is a nice data structure in Java that can grow and shrink. So you're going to use it all over the place. Right, so here's the star class here. One thing I forgot to put on the star class, but I'm going to do it now because it's a really good idea to do this. And that's to put a method on it called a ToString method. So the ToString method looks like this: public string ToString. And what does this ToString method look like? This is a method that converts this Java object to a string, often for the purposes of printing the Java object. But for whatever purpose that you might need to create this, basically generate a string from this object. So a ToString method could look like this. So we're going to return the display name field. And then I'm going to append, say, a /t for the tab character, plus, let's see, we're going to print the hab character, or the hab flag field, plus another tab character, plus, let's do the xg, plus the tab character. I'm getting tired of typing the tab character, so I'm going to copy and paste this code here. So we've got xg plus yg plus the tab character plus zg. So I'm going to print all of those. Was that them all? Oh yeah, we had the absolute value, so let's print that out. Control V, and then we're going to print the absolute value, or the absolute magnitude. So there's AppsMag, right? So, and it's HAB for hab. Okay, cool. That's called a ToString method, right? So that's just useful. And then I'll show you how this works in a little while. When we actually load up our data set into these array of these star objects, into this array list of star objects, then we'll be able to use the ToString method when we're iterating over that array list to basically print every element to the screen. So here's the star map code here, right? And for table row, table rows. Now I want to create one of those star objects, and I want to create it from the display name and the hab and so on. So there's several ways we can do this, okay? What should we do here? Okay, let's just do one. We'll create one, and then we'll print them all out, and then we'll move on, and finally we'll store them all in an array list. Okay, so let's just create one every time around. Let's go. Star equals new star. So now I'm creating a new instance of that star class, and you can go star.set display name, and I'm going to set the display name from, say, the row dot get string, and then I'm going to pass in, say, display name, like that. Okay, cool. So that's hopefully going to work. Okay, let's see, that's creating the star, and then I'm going to go star dot set hab, so that's going to set the hab flag, and that's going to be from row dot get int. Now, to be very safe about this, I'm actually going to copy and paste those column names directly from the CSV file, because it's too easy to make a mistake and then the column names don't match up. So there's the hab flag. Check to make sure my video is still going. Yes, excellent. Okay, so here's the star map class, and paste that in there. There's the hab thing. Next of all, star dot get set x ct. So set xg, and that's going to be row dot get string. That column is called xg. So what can we say here? Set xg row dot get string. That should be get float. All right, and that's going to get a floating value. All right, so the interesting thing here is this method is getting quite long, right? And if you think about it, what I really want to do is I want one new star object from every row. So wouldn't it make sense to just pass the table row into the star object and have the star construct itself from the table row? And that's a good example in Java of where we might use this thing called a constructor method. So let's refactor our code at this point to use the constructor method. Yeah, let's do that. Okay, so here's the star class, and let's put our constructor method in here. Doesn't really matter where you put it. Hang on, my dog's trying to get in. So let's make the constructor method. Public. Oh yeah, what is a constructor? Constructor, a special method that gets called when the object is created. And you can pass parameters into the constructor method, and they basically customize how the object is created. So you can, for example, set the values of private fields or allocate the sizes of arrays and so on inside the constructor if needs be. In this case, what we want to do is just assign the private fields of this class from the columns from each row from the data set. So we can take a table row. Table row is a parameter. Table row, let's call this row, and let's do the actual assignment of the fields in here. And just to show you, it says cannot be resolved to a type. So we'll fix that by clicking this little light bulb, and we want to import table row from processing.data. Cool. So let's put this import processing.data.table row statement at the top of the star class. And here we go, star the table row. So I wonder, can I just copy and paste this code? Let's copy. No, we don't really need to. We can just retype it. It's quick, because there's not that much useful stuff we can get here. So let's go back over to star here, and this time we'll go display name equals row dot get string display name with an uppercase N. And let's go. The hab flag is going to be equals to row dot get int open bracket invert commas hab question mark. And then we have xg is going to be equals to row dot get float inverted commas xg. We'll do the same for yg and zg. Yg, zg, yg, zg, and then we'll do the final one for abs mag is going to be equals to row dot get float. Let's go back over to our data set and then find the column to make sure it's called abs mag, exactly like that, because its spelling needs to be exactly the same. So here we are in star and then abs mag. Excellent. Okay, so that's our constructor. So this is a useful constructor because this is a constructor that basically assigns all of these private fields from these columns from the table. So I can basically say this row becomes this Java object. So over here in star map, now there's no default constructor. By the way, in Java, here's one of the rules. If you don't put a constructor on a class, you get a default constructor. But once you put a constructor on a class, the rules change. And the rule now becomes you have to use the constructor. You can't use like this imaginary default one that Java makes anymore. And I suppose like if you think about it, that makes sense because once you put a constructor on a Java class, you're basically saying this is how you should construct this object. And it's no longer kind of like, you know, it's no longer okay to construct it with no values. You got to construct it with a table row. That's the only way to make this Java object. So over here in star map, we can now go equals new star row. And then I can go system dot out dot println star. And here's where our ToString method gets called. So you notice I haven't gone star dot ToString because you don't have to. The fact is, println expects a string, and so in Java, when something is expected as a string, the ToString method on the object gets called. So star object here gets created from the table row. Going to print out each row using the ToString method that we previously made on the star object. So let's see how we are getting on this program so far. By hitting F5, maybe everything will compile. Everything compiles and runs. And then here we go. We get an exception, right? So this table has no column xg. Let's fix that. So let's go over to star here and find out what that column is called. I think it's called xg the other way around, like this. xg. But let's go to the data set and just verify that. Yeah, so it's xg, yg, and zg. xg, yg, zg. And let's hit F5. Save program, compile and run again. And now we have now we have the ToString method getting called, and this is basically taken, you know, each of the private fields, separated them with the tab, and that's what the ToString method has done. That string gets returned and then gets passed into the println method, and it gets printed to the screen like this. So here we go. The last thing we're going to do in this program is, okay, because you can see what's happening here. Open close brackets, that means star is like a local variable. But because it's a Java object, it's a local variable that gets instantiated into a new instance of the star class, gets printed out, and then what happens once we reach this last line here? The Java object gets tagged as being no longer used, and therefore it's eligible to be garbage collected. And so this object will get garbage collected after a little while. So what we want to do instead is store all of these newly created Java objects into our array list. And our array list, like I say, is like it's like an array. And in fact, an array list is actually an array. It's actually stored as an array, but it's encapsulated into a Java object which manages the memory for the array. So if the array list gets too big, it allocates more memory and so on. So this is what an array list looks like in Java, right? The syntax is different to an array. So a or a y list. Okay, and then you go open angle bracket, and then you put the type of data that the array list is going to store. So it's going to store a star object. So array list star, and then let's give it a name. So that's the type. It's a type of array list for holding stars. The name of the variable is called stars, and then let's allocate some memory for it by going equals new. Oop. What have you done? Array list. Open angle bracket star, close angle bracket, open and close brackets to say call the array list constructor. And that should be equals new array list, like that. Right, so that's how you allocate an array list for holding stars. So it's array list, open angle bracket, the type, the variable name, equals new array list, open angle bracket, the type, close angle bracket, and then close, open and close round brackets to say this is calling the default constructor, and then semicolon at the end. So I've made this, by the way, because it's here, it's between this curly bracket and this curly bracket for star map. It's now a field of the star map class, and I can use it in any of the methods. And in fact, let's make it a private field. So it's a private field, okay, and it's called stars. So there's star allocated, and instead of just printing out the stars like this, we're going to go and add them to the array list. So let's add them to your array list. Stars is the name of the array list. Dot add is how you add something to an array list. And then we're going to add that star object. So now there's a reference to this star object held in the array list, and the star object will no longer get garbage collected because it's stored in the array list. And so I'm just going to write one final method here to just print out all of the stars. Okay, just to show you how you can iterate over an array list. So let's go public void print stars. So again, lots of ways we could write this: an ordinary for loop or the Java for each loop. Let's write it using a for each loop. For star colon star. Sorry, star in sorry, wrong language, colon stars. Okay, for star colon star, and that means stars is this array list object, and it's one of these iterable things, so you can write it using this for each loop, and that means that each element in the stars array list will get copied one by one into this variable star, and then this block of code gets executed for this star variable. And so this is like a for each loop. It's like saying for every element in the array, do this block of code. So I could just call system dot out println star, and let's copy and paste that code from load data to make that code execute. So now load data is going to load every element from that table into the star array list, and then print stars is going to iterate over that array list, and it's going to call the ToString method implicitly on each one. So let's hit F5 and see if everything works. So there we go. So that concludes part 1 of this video. You can get all of the code on the Git repo, which I will link to in the comments for this video.